On graph paper, using a scale of 1 centimeter to 1 unit on each axis, draw the axes so that x is greater than or equal to 0, and x is less than or equal to 16, and y is greater than or equal to 0, and y is less than or equal to 16. L is the point 28. The vector Lm is given by this column vector 6, 8, and the vector Ln is equal to this column vector 12, negative 5. And part B says plot the point L and draw the vectors Lm and Ln. And so let's do part A, all right? So part A, what they want us to do is they want us to go in the graph paper and use a scale of 1 centimeter to 1 unit. And we have x has to be from 0 to 16, and y has to be from 0 to 16. So let's first do that. So if you look here, we have this graph. And if you look on the y-axis, right, the y-axis starts at 0. Let me go 1, 2, 3, 4, 5, 6, all the way up to 16. And they say 1 centimeter equals to 1 unit. So that means that each block, right, is 1 centimeter. So this goes from 0 to 1. And then we go to the next one, and that's 2. Let me go to the next one, that's 3. That's what they mean by 1 centimeter to 1 unit. That means that with each block, that's going to be a different number. All right, so 1, 2, 3, 4, 5. We don't skip, right? And then the same thing on the x-axis, right? They say the x-axis, we start at 0, right? And we end at 16, all right? And so that means that each block, right, is a different number, all right? Every 1 centimeter, you put a different number. And so with each 1 centimeter, you increase. So this go 0, then 2, then 3, then 4, then 5. So 1 centimeter equals to 1 centimeter to 1 unit. All right, that's what they said. They said 1 centimeter to 1 unit. And so with each 1 block, with each 1 centimeter block, we increase, we change our numbers. All right. Okay, so we go from 0 to 16 on the x-axis, and the same thing for the y-axis. We go from 0 to 16, right? That's the first thing that we do. And we put y-axis, we label it, and we put the x-axis, okay? So that's good. What else do they want us to do? They say L is the 0.28. So we have to plot the 0.28. So this is 2 on the x-axis, right? Like they say L is the 0.28. So 2 on the x-axis, but 8 on the y-axis, all right? So L is the 0.28, all right? So this is the point L. So we plot and label the point L. Now, what else they want us to do? They say they want us to plot L and draw the vectors Lm and Ln. So they tell us that Lm is equal to the column vector 6, 8. So we start at L. Then this says this 6 means, this positive 6 means that we move 6 times to the right. And this positive 8 means that we move 8 times up. So the top number is X movement. The bottom number is Y movement. So the 6, since it's positive 6, that means that we move 6 times to the right. And since this is positive 8, it means that we move 8 times up. So we move 6 times from L. 1, 2, 3, 4, 5, 6. Then we have to go 8 times up. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so that means the point M is right here. Let me draw a line. All right. And we put our arrow. So this is the vector LM. All right. This is the vector LM. Okay. Next, we have to do Ln. Okay, so the positive 12 on the X means that we move 12 times to the right. And the negative 5 means that we move 5 times downwards. All right. So we start at L and we move 12 times across to the right. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. we move 5 times downwards, it's going to be 1, 2, 3, 4, and 5. And so this is where N is supposed to be. And then we draw a line from L all the way to N. We put our arrow, okay? And we indicate that this is the vector Ln. I should also put that on the side as well for the vector Lm. I didn't label that Lm. So let me put it right there. So this is the vector L, right? Lm. Okay, so let me put that right there. Okay. Okay, so that's good. All right, so okay, so that's what they want us to do. We already plot this point, and we already draw the vectors Lm and Ln. So what else we need to do? Well, they said write the vector Mn as a column vector. Now, where's the vector Mn? Mn means that we start at M and we go to N, all right? And so we have to write that as a column vector. So let's go across. So we're gonna go across. It's gonna be 1, 2, 3, 4, 5, 6. So 6, positive 6 on for the X component. And then we move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So positive 6 for the X component and negative 13 for the Y component. And so the vector Mn is going to be 6 because we move 6 times to the right, and negative 13 because we move 13 times downwards. Okay, so the vector Mn is equal to 6, negative 13 written as a column vector. Okay, next we have to calculate the magnitude of the vector Ln. So calculate the magnitude of the vector Ln. Okay, now, so what is Ln? What is Ln? So Ln is right there, written as a column vector, is 12, negative 5. And we can also show it. So this is the vector Ln, right, on the graph. So we know that its column vector is 12, negative 5, and we need to find its magnitude. So the magnitude of Ln, we know that it's 12, negative 5. So its magnitude is going to be the square root of, you take the X component and you square it, and you take the Y component and you square it, and then you add the results. So it's going to be 12 squared, which is 144, and it's negative 5 squared, which is 25. So 144 plus 25 is equal to 169. So we have the square root of 169, and the square root of 169 is 13. So that means that the magnitude of Ln is equal to 13. Okay, what else do they want us to do? They said that P is the midpoint of Lm and Q is the midpoint of Mn. G lies on LQ such that LG 2GQ is equal to 2 to 1. Write down as column vectors LP, LP. Now, the first thing that we have to do is we have to figure out what is P, right? We have to express that on our graph. Like, what is P? We have to figure out what P is. But the good thing is that they tell us that P is the midpoint. And so that means that it's going to be in the middle. And so in order for us to find LP, we have to first find out P. So let's do that. So I have P right here. And you may be wondering, well, how do I know that P is right here? Well, you have to find, remember, P is the midpoint. So that means that if P is the midpoint, that means that LP and PM must be equal to each other, because this is the middle point. This is the point that is in the middle of this line. So that means that these two halves must be equal to each other, all right? And so you could find P because all you need to do is you say, okay, well, if we start at L, right? And then we move, how much we move? We move 1, 2, 3, right? So let me actually show it. So if you look carefully, so we move 1, 2, 3, right? So we move 3 here, and then we move 1, 2, 3, and 4. So that means on the Y, we move 4, and on the X, we move 3. Now, in order for P to be the midpoint, we have to have these exact measurements. If not, then we know it's not midpoint. So this is gonna be 1, 2, 3. So we have 3 here. All right, and then it's gonna be 1, 2, 3. I'm sorry. Let me do it again. I'm sorry. Let me move that. So it's going to be, let me use the pen. So this is going to be 1, 2, 3, and 4. So again, we have 3 times we move in the X direction, and 4 times we move above. So that means that P is the midpoint. So that's how I figured out that this point is the midpoint. You have defined a point on this line such that it's the middle, and such that you have what we have here, that this line is equal to this line. And you know that LP would be equal to PM, because if you could show it, when you move in the X direction, it's the same as when you move in the X direction here. And when you move in the Y direction, it's the same amount as when you move in the Y direction. So you know that these two, LP and PM, are equal. So in order for you to find what P is, right, the midpoint, you just have to find a point such that these two lines would be equal to each other. And when I did it, I found that this is the point right here, the point 5, 12, right? That's the point where it's actually the middle of this line. Okay, so that's how you could figure out what is the midpoint, and that's how you actually could check if the point that you chose was the right one. So I chose this point, and it was the right point, and I showed you how you can verify that's the right point, and indeed it's definitely the right point. So P is right here. This is P because it's the midpoint, and that's how we verify that this P is actually right. So whenever you have defined your midpoint, just find a point that is on your line such that it cuts the line into 2 equal parts. Okay, so now what they want is they actually want what they say that they want. They want the vector. They want LP written as a column vector. So that means that we have to go from L to P. So let's do that. It's gonna be the same thing. 1, 2, 3, and then it's gonna be 1, 2, 3, and 4. So 3 for the X component and 4 for the Y component. And so that's what the vector LP is, because we're moving from L to P. And so the column vector LP is, oh, what do I have? Okay, how did I did it? I did it, okay, I did it this way. Okay, so I showed you how you could do it graphically, just by doing 1, 2, 3. That's 3 right there. And then 1, 2, 3, 4. And then your answer is still 3, 4. But I did it a different way. I said, okay, P is the midpoint of LM. So this is how I actually showed the working. I showed you how to do it graphically, but I went ahead in this instance and I actually wrote down the working. So I said, okay, P is the midpoint of LM. So if P is the midpoint, that means that of LM, that means that LP must be half of LM. And that makes sense because P is the midpoint. So that means that, let me just show you. Since P is the midpoint of LM, right? Since P is the midpoint of LM, that means that LP is going to be half of the entire line, right? That's what I basically am saying, right? So since P is the midpoint of LM, that means that LP must be half of LM, right? And so that makes sense. So that means that LP is half of LM, but what is LM, right? LM is 6'8", and how do we know that? We know that LM right here, we have right here, LM is 6'8", all right? LM is 6'8", and LP is half of that. So the vector 6'8" is here, and we have a half times this vector. And so we multiply a half by 6, and we multiply a half by 8. And a half multiplied by 6 is 6/2. And a half multiplied by 8 is 8/2. 6/2 is 3, and 8/2 is 4. So that means that LP is equal to 3, 4, right? That's how we can write it as a column vector. Or, so you could do this working. It's only for 1 point. So you could also look at the graph as well, and you could figure out what LP is. You just could, move along in the X direction. 1, 2, 3. So that's your first component, and then you move along in the Y direction. 1, 2, 3, 4, and you'll get the same answer. 3, 4. Okay, and so that's how we get the vector LP as a column vector using the graph and also using algebra to help us as well. Okay, so that's what LP is. LP is the vector, the column vector 3, 4. Okay, now they want us to write down as column vectors NP. Okay, so NP, let's show it graphically first. Okay, I think that's the only way I showed how to do this, but let's see. But let's definitely show it graphically. Let me check. I think that's the only way I showed it. So okay, so how are we gonna get NP? NP means that we start at N and we end at P. So we start at N and we end at P. So let's go here. This is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So that means that we are going to move 9 times left. And so that's going to be -9 for the X component. And then we move 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means that we move 9 times up. So that means that's going to be +9. So -9 for the X coordinate and +9 for the Y component. So -9 for the X component and +9 for the Y component. And so NP, the vector NP is equal to -9 and 9. And so I just did this using, the graph. Okay, so let's move on. Now it says write down as column vectors. We have to write down LG as a column vector. Now, okay, so LG. So it says that Q is the midpoint of MN. That's important and find out what LG is. And it says G lies on LQ such that LG to GQ is 2, 2, 1. So the first thing that we need to find, even before we figure out what LG is, we need to figure out what is Q, right? Like, let's figure out what Q is, and then that'll be able to help us to figure out what LG is, right? They said that Q is the midpoint of MN. Okay, so Q is the midpoint of MN, right? Okay, so how do we know what Q is? Now, I figured out that Q is right here, right? This is the point Q. And let me give you the exact coordinates. It's going to be 11, right? 11. And on the y-axis, it's going to be, let's go over. That's 9.5, all right? So the coordinates of Q is 11 and 9.5 if we go over. Now, let me show you as 9.5 because this right here is 9, right? And you go 9.2, and you go 9.4, and then you go 9.6. But the point Q is in between 9.4 and 9.6. So this point Q is in between 9.4 and 9.6. So it's 9.5. So the coordinates of Q is 11 and 9.5. But how do I know that this is the point Q? How did I figure it out? Well, remember, you can figure out what Q is because Q is just the midpoint of MN. That means that it's the point that's in the middle. So you have to figure out, okay, what point is in the middle of MN such that when I find this point, right, MQ and QN are the same, right? They are equal in length, all right? And I can show you that this is the midpoint because if you notice carefully, right? If you notice carefully, let's do this. I can show you that it's the midpoint. So if you look at M, let's go over, this is going to be, let's say that we go, this is going to be let's go in this direction. So we go, this is a half, right? This is a half, right? Then after half, we have 1, 2, 3, 4, 5, 6. So basically, this is 6.5, right? So 6.5. Now in the x direction, we go 1, 2, 3. So this is going to be 3 times to the left. So, okay, so what do we have? We have that for the y component, we have 6.5. Why? Because it's going to be a half. 1, 2, 3, 4, 5, 6. So it's 6.5. And then we move 3 times. So it's going to be 1, 2, 3, right? So we have 3 and we have 6.5. Now, technically, if we were actually writing the coordinates, the components, this would be -3 because it's going to be -3 because we move left. But it's fine because we just want the amount of times. We don't want the signs now. We're just trying to figure out, okay, how many times do we have this? Okay, and the reason why that's the case is because we could also go, down 6.5 and then across 3 times. So it's fine. So okay, let's see if we have the same numbers, right? We just worry about the absolute value of the numbers now. We don't worry about the sign at this point because we're not trying to do the components. We're just trying to figure out the length, right? Okay, so let's look at this. This is going to be, we move a half, and this is going to be what? 1, 2, 3, 4, 5, and 6. So look at this. This is also 6.5, right? On the y. Okay, so 6.5 in the y direction. And let's go across. It's going to be 1, 2, and 3. And so again, we have 3. So in the y direction, in the y direction, we have 6.5. Same thing with this. In the y direction, we have 6.5. In the x direction, we have 3. And in the x direction, we also have 3. So that means that this point has to be the midpoint. So whenever you're trying to find the midpoint, just look for that point such that this point cuts this line MN into 2 equal halves. And you would know that it is equal if you can verify that the movement in the y direction, the movement in the x direction are equal for both sides. All right, just like how we have it here. So now that we know that the point Q is the midpoint, we just verified that that's the midpoint. And so now we can move on and proceed with the rest of it. So we know that Q is the midpoint, okay? And it says that G lies on LQ. So this point G lies on LQ. Now where's LQ, right? LQ is this line from L all the way to Q, right? So G is on this line LQ, all right? Okay, so LQ, so G lies on LQ such that LG to GQ is equal to 2 to 1, all right? Now, so let me draw it. So if we have the point L, so let's call this the point L, and then we have the point Q, right? The point Q is right now. They're telling us that LG is going to be right. LG is going to be on this line LQ. So G is going to be right here, all right? And it's going to be such that no, it's just I need to do this a little better than this. So let me erase this. Let me put this. So let's say that this is right here. So this is Q, right? And then this is right now, right? So G is going to be, like they said, that G is on this point. So this is G, right? And so G is on this point, but G lies on LQ, right? So G lies on this line LQ, and it follows a particular ratio. So what's the ratio? So LG, right? LG to GQ, because this is LG and this is GQ. They follow this ratio, and the ratio is 2 to 1. All right. So 2 to 1. All right. So that means that, okay, so if this is 2 to 1, right? That means that the entire line is going to be what? So LQ, if this is 2, right? If this is 2 equal parts, if LG accounts for 2 equal parts, and GQ accounts for 1 equal part, that means that the entire line is 3, right? So what does that mean? That means, right? That means that, what that actually means is that since the entire line is 3, right? That means that we can say that, okay, well, that means that, let me change the color. That means that LG is actually 2 out of what? 2 out of 3, right? Because LG accounts for 2 equal parts, but 2 equal parts out of how many? What's the total amount of equal parts? The total amount of equal parts is 3. So LG is actually 2 over 3, right? And what is GQ? Well, GQ is going to be 1 out of 3, right? And it makes sense because if we add them together, we get 3 out of 3, which is a whole, okay? So what do we have? We have that LG is equal to 2/3 of this entire line LQ, and GQ is equal to 1/3 of this entire line LQ. All right, so I want you to understand that. So that's how we can interpret this. If they tell us that LG to GQ is 2 to 1, that means that LG is 2 out of 3, right? And GQ is 1 out of 3, all right? 2/3 of this entire line is LG, and 1/3 of this entire line is GQ. And so that means that, okay, if we have LG to GQ is equal to 2 to 1, what does that mean? Well, that means that LG, this is LG is 2/3 of the line LQ. All right, so that's what we wanted to write. That's the equation that we wanted to get from this particular statement that they give us. All right. So LG is equal to 2/3 of LQ, right? Now, what is LQ, right? What is LQ? Let's go and figure out what LQ is. So LQ means that we go from L all the way to Q. And so let's do that. So LQ is going to be, let's do this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9, right? 9 in the X direction. And it's positive 9 because we're going to the right. And then we have 1. And then we have 1.5. All right, so we have 1 and then 0.5, which means that on the Y direction, it's going to be 1.5. And so that means that LQ is actually equal to what? 9, right? I'm sorry, yeah, 9. 9 in the X component, and then on the Y component, we have positive 1.5. That's what LQ is, all right? And it's good that we know what LQ is because then we know that LG is equal to 2/3. So LG is equal to 2/3 of LQ. But what is LQ? LQ is 9, 1.5. Next, we multiply 2/3 by 9. And 2/3 multiplied by 9 is 6. And 2/3 multiplied by 1.5 is 1. So LG is equal to 6 and 1. All right, that's what LG is. LG is equal to the column vector 6, 1. And that's why we know that that's why we could actually plot out the points. That's why we could actually plot out the point G, all right? Because we know that LG is 6, 1. And I think that's the next question. The next question says write down the coordinates of LG. I'm sorry, write down the coordinates of G. Well, we already know that LG is 6, 1. So if we move in from L to G, it has to be 6, 1. So that means that we move 6 times across. So it's 1, 2, 3, 4, 5, 6 and then 1 above. So it's going to be 1. So that means that this has to be the point G. Now, what is G? Well, G is 8, right? 8, 9. That's the coordinates of that point. 8, right? 8, 9. And that's the coordinates. And so the coordinates of G is definitely 8, 9. That's the coordinates of G. The coordinates of G is 8, 9. Okay, next it says, given that NG is equal to K and P, calculate the value of K. Okay, so NG is equal to K times NP. And so what is NG, right? What is NG? Well, what is NG? I have NG as -6 and 6, and I have NP is equal to -9 and 9. But let's verify that using the graph, right? So NG, so let's go on the graph. Let's go on our graph. We're trying to figure out NG. So NG, that means that we're gonna go from N to G. So let's show that. So NG is gonna be 1, 2, 3, 4, 5, 6. So that's gonna be 6, but -6 because we're going to the left. It's gonna be 1, 2, 3, 4, 5, 6. So that means that NG, right? NG is equal to -6, right? And 6, +6. Because we move 6 times to the left and we move 6 times above. This is going to be NG. That's what NG is. -6 and 6. That's what NG is. All right, what else we need to know? We need to know what is NP. Okay, NP means that we go from N to P, and we did this already, but let's do it again. We're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, stop at 9. Let's do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. So 9 times to the left, so that means that's gonna be -9. And it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 9 times above. Okay, so that means that NP is actually -9, 9. And so we're good. So NG is -6, 6, and then NP is -9, 9. And so there we have it. So NG is equal to -6, 6, and NP is equal to -9, 9. And they want us to figure out what is K, right? So we're gonna take K, we are multiplied by -9, and we're gonna take K and we multiply it by 9. And so we have K multiplied by -9 is -9K, and K multiplied by 9 is equal to 9K. So we have -6 is equal to -9K, and then we have 6 is equal to 9K. So we have that this matrix is equal to, we have that this factor is equal to this factor. And if these two vectors are equal, that means that corresponding entries must be equal. And so what does that mean? Well, that means that -6 must be equal to -9K, because these two corresponding entries must be equal if we say that the vectors are equal. So we have -6 is equal to -9K, and we're trying to solve for K, so we divide both sides by -9. We cancel this -9 with that -9, so we get that K is equal to -6 divided by -9, and so we get that K is equal to, well, I just canceled out the negatives. So we get that K is equal to 6 over 9, and 6 over 9, if we divide both top and bottom by 3, we get that K is equal to 2 over 3. So that's what K is. K is equal to 2 over 3, and that's what the value of K is. We can also do it on this side as well. We can do 6 is equal to 9K, and 6 is equal to 9K. So that means that we divide both sides of this equation by 9. We cancel this one with that one. So we get that K is equal to 6 divided by 9. We divide top and bottom by 3. So 6 divided by 3 and 9 divided by 3. And 6 divided by 3 is 2, and 9 divided by 3 is 3. So we get that K is equal to 2/3. And it's the same thing. K is equal to 2 over 3. And that's the answer to this question. Do we have any more parts? No, we do not. Okay, so that brings us to the end of this video. Thank you for watching, and I'll see you in the next video.